Hello class, reporting from South. There are two questions which I want to take today. One is about there is a sphere. There is a sphere which is rolled with angular speed omega naught and is dropped. That means initial speed is 0 on a plank of certain mass. Plank in turn rests on a smooth surface. Smooth. As it falls, what happens? It is in touch with the plank for some time and then leaves the plank. So, leaving the plank can happen under two circumstances. First thing first, it is to leave the plank, there is no two way about it. It will be leaving the plank. There is coefficient of restitution given to us, and that coefficient of restitution, let us say, is E. It hits and gets reflected, it will leave by some velocity. It will move vertically upward with EV naught and will gather some component of velocity in horizontal direction as well. Question over here is, will it move slipping on or without slipping on? When it moves, I don't want it to slip. I don't want the sphere to slip on the plank. So what should be minimum value of mu in order to actualize it? It leaves the plank without slipping on it. For this, what should be the minimum value of mu between plank and the sphere? That is what we have to calculate. This is one question, question number one. How will we go about it? Think what will happen when it hits. This will start moving in certain direction. As it is rolling on this, force will be Fs is what I am taking in the forward direction on the sphere. This is on the sphere, post or at the time of collision. And this will be on plank. We calculate. Let me take this small m and this gap. Plank this way, sphere that way. One plank, Fs is acting in this direction, so it starts moving in this direction. On a sphere, Fs is acting in this direction, so it starts moving in this direction. V small m. This for sphere. Sphere will also move upwards as there is coefficient of restitution, so E V naught upwards. What are the equations that we can get? One of the equations that we can get for the sphere will be n dt integration, change the momentum. This is the only force for the vertical direction. So final minus initial. This to get me E taken, E plus 1, V not taken outside. This is for n dt. N dt, the impulse in the upper direction of the sphere, which is giving me that equation. Now, as it hits, there will be force on it, force be shown in this direction. This force will try to stop or reduce omega naught. If it is trying to reduce omega naught, then the torque equation suggests omega minus omega naught minus or minus if you take, let me write that down. I'm assuming omega is clockwise eventually, you can take omega as anti-clockwise, whatever direction you take. You know, if slipping is not to take place, then omega should remain. The direction of the sense that it is in, we call sense. Clockwise, the clockwise sense should remain. So, supporting friction, let us say I am taking omega anti-clockwise. So, omega minus of omega naught will be what to us? Fs by Fs into R I naught into t. This omega is clockwise. Why? Because Fs is in which direction? We have no idea which direction is trying to rotate it. It is trying to rotate it anti-clockwise. So this omega is also anti-clockwise. Omega naught is clockwise. Omega is anti-clockwise because I am taking that being provided by FSR. FSR is anti-clockwise of this pair. What we then see from here is omega plus omega naught is equal to Fs into R by I naught into T. If I have misspelled it, I am spelling it again to you. This omega is supported by FSR, therefore this omega is in anti-clockwise sense. Omega naught is the clockwise sense. We have taken this omega naught, this one, this omega is in anti-clockwise sense. But we require omega clockwise. So what we do, we take negative of omega. When you take negative of omega, what we get to see from here is omega naught minus of fs r by I naught into d. This omega you can say negative, or you can simply write this omega in what sense? In clockwise sense. Clockwise. So this omega we take in clockwise sense. We know that if the sphere taken is to roll without slip, then v should be equal to omega r. This point v will be how much to us? This point v will be omega into r, which is in this direction, minus, it has gathered this, so vm, right? This should be the case, and this should equate to omega into r. Right? Which omega? Which omega? This omega is post collision, correct? Right? Omega minus VCM. This is what we are getting for this point, right? Correct? And this point to slip without, this point should not slip. If this point is not to slip, then you can remove this, we can mark it as V capital. Right? This is V capital. What we get to see from here is omega r minus Vm is equal to V capital. This is the equation that you are getting. You can mark this as equation number 2. Okay? This is what we have to work on. I think it started lagging, so I'll take a break here before we begin again.